5.7 says H is a tangent to G at R, a point in the first quadrant. Calculate T such that y is equals to f of x plus t intersects G at R. So H is a tangent to G at R. And then they say in the first quadrant. So H is a tangent to G. G is this function. So we have a straight line that is a tangent to this hyperbola. And we can call this point where they meet R. Not sure it can be anywhere along this line, but we're just going to pick this line. So H is a tangent to G at R, a point in the first quadrant. Calculate T such that y is equals to f of x plus t intersects G at R. So how should we move f? By how many t units should we move f such that it also is intersecting that point at R? Or such that it is intersecting G at that point R. So H is a tangent to G at R, a point in the first quadrant. Calculate T such that y is equals to f of x plus t intersects G at R. First thing we're gonna do is write the equation for h of x as h of x is equal to minus 2x plus 8, since h was already defined in the previous question, and if it's intersecting the first quadrant, that means it will be intersecting at that point 8 units above, or rather 8 will be the value somewhere over there. But anyways, we found this 8 and minus 8 in the previous question when we're looking for possible values of k. Cool. So now that we've gotten our value for h, or gotten our equation for h, let's equate it to the hyperbola. So minus 2x plus 8 is equal to 8 over x, such that we can find what is this value over here, this x value here. So multiplying everything by x, we get minus 2x squared plus 8x, and then that 8 that's left, bring it to the other side, we have 0. Divide everything by minus 2, we get x squared minus 4x minus, or rather plus 4. And then we open up our brackets to have this. Then factors of 4 that we can place in here, that would be minus 2 and minus 2. Add them up to get minus 4, multiply them to get positive 4. Cool. So our value for x is 2. That means this point here is 2. So now we need to figure out what the value of our of this function is, of the parabola is at 2, such that we can bring it down to this value over here. So if we look for f of 2, we substitute minus 1 over 2 over 2 minus 1 squared plus 8. So again, we have already solved for this, which is which will be the value 2 minus 1 is 1 squared minus a half. That would just be 8 minus a half, which is 7.5, or rather 15 over 2. So 15 over 2 is the value that we currently have. That means that this approximate drawing is in the incorrect position. It should be somewhere over here, rather. But anyways, we now have the value of a function at that point. Now what we also need to do is figure out what the value of our straight line is at the coordinates of 2. So what is that straight line that we had drawn earlier? what is its value when x is equal to 2. So to put that in, we find h of 2 is equal to minus 2x, replace that with 2, and then we say plus 8. This value gives us 4. So to get from 15 over 2 to 4, we basically now are going to write the new function that we have as, we have y is equal to f of x plus t. So we want y to be 4, where f is currently 15 over 2 plus t. Take 15 over 2 to the other side, you get that t will be equal to minus 7 over 2, which makes sense if you think about it, because t has to be negative. If we move this function by 7 over 2 values or units downwards, it will come to the point of intersection somewhere over there. And that is what we are looking for.